Like, let me just say a phrase that you should be well aware of. Common Core. If I say the phrase Common Core, does anyone know what that is? Has anyone ever heard the phrase Common Core before? Yes? I'm not going to make you define it, but it's just a set of standards for teaching certain subjects. Common Core math stuff, a lot of it I like, a lot of it I don't. I'm going to point out this semester, and again, I can't remember if I said this before. Facebook is basically an online site for old people nowadays, but very often you'll go on there and somebody's posted a picture of their kids' work, their kids' homework, and they're like, we didn't learn this shit, There are steps you need to take a human through in their evolution of understanding mathematics that does not look like the end result, right? But we need to understand how we get there. So a lot of times parents will look at what you're doing with their kids and they'll say, that's not how I do it, what are you doing? It's like, no, it takes a while to get to where you can multiply, you can carry the one and all that shit. That's not something that makes immediate sense. Are you guys all with me? So every now and again this semester I'll point out, here's a place where parents will not understand why you're doing this, right? So you have to be ready. Because you guys, there's one thing about working college that's awesome, and also bad, sort of, is I don't have to work with parents. I do. There are parents I would love to work with, but there's a lot of parents I'm very happy I don't have to. Are you guys kind of with me? So if somebody calls me, and this has happened, somebody calls, hey, so how's my kid doing? I told him, you better pass or else I'm not going to, I'm like, talk to the kid. But, they're a person. It's their own business. I'm not going to give their business away. You guys, it's not going to be the student's business. It's the parent's business because they're underage. So you're going to have to work with parents. And one thing you're going to have to do is to explain to them why you teach things a certain way. To kind of bring a student from zero understanding to something. You can't just go, bam, right? All right, you guys semi with me? All right, so Common Core is a set of standards of how to teach certain subjects, math being one of them. There's also, so in the front of the book, every now and again, I'll point this out. So we're in chapter 2, right? So at the beginning of chapter 2, let me see where they put this. They have these standards. So here, here. The NCTM is the National Council of Teachers of Mathematics, right? So you have those standards. They have Common Core standards. Are you guys all with me? At some point in your education at Grossmont or wherever you end up taking most of your elementary ed courses, they will go over these standards. I don't think anybody's hit that yet, have you? In any course you've taken? Very curious. What is your elementary ed course like? What are you going to take after this? Like 126? You're going to take 126? And just to let you know, I'm hoping I can teach that next semester. So if you end up really not liking me, I'm sorry. I'm going to be teaching. I'm going to be teaching 126 next semester, right? Almost definitely. Do you take another course, like an elementary ed course specifically, or do you take child development or something? Or yes, okay, we're good. Just out of curiosity. I'm not sure where you're going to get more specific information about these. I just want to show you at the front of every chapter, they tell you the established standards and how it relates to what that chapter discusses. Okay. I'm not going to necessarily go too deep into that because I don't see that as what I'm doing with you. I'm trying to get you to understand the mathematical concepts themselves. But those standards exist, and you should really kind of look them up yourself. Do anybody in here have any children of your own? Yes, okay. So you would be interested in this stuff on another level. As a parent, you want to know, what are these schools going to expect my kid to know? Yeah, okay. Okay. So before I jump into where we left off, one last question. Anything else? Any questions from anything? We're going to basically go back over what we did in 2-1. My plan today is to do 2-1 and 2-2. And then on Tuesday, I'm going to bust out of those cabinets your first example of manipulatives. The stuff your students could be using to learn fractions and base 10 numbers and so forth. We're going to learn base 3 numbers, for example. The shit we'll talk about later. Okay. So if nobody has any questions, yes?
Will you continue to post the pictures of the homework? Just because my book still hasn't arrived.
If you, I feel okay with maybe doing the first few assignments. So if you email me or remind me, I can scan section 2.2.
Okay.
But I definitely can't do that for too
Oh,
long.
yes.
Because then,
I get in a lot of trouble.
Okay. I'm flying under the radar at the moment, so we'll see. Yeah. Just remind me. Just send me an email. I can put another. Yeah.
Thank you.
So just remind everybody. Section 2 on homework. There's a scan of it in Canvas in case you don't have your book yet. You can also. They should have a copy of the book in the Mass Science Center. If you go in there, you can check it out while you're in there. Okay. All right. So let's kind of pick up with what we got into last time. The very first thing I kind of talked about that relates to section 2.1 is the idea of putting the projector right. No, one-to-one correspondence. And just to let you know, I am going to talk a lot, and then I've got a worksheet where I'll finally shut up and let you guys do some stuff. I understand you're like, when is this guy going to shut up? So, we talked about a one-to-one correspondence a little bit before, but I'm not sure if you guys could articulate for me what it means. One-to-one correspondence. So, for example, if I have a set A, B, C, and then now I've got the Jackson 5 in my head, A, B, C. Is there a one-to-one correspondence that exists between these two sets? Yes. Even if you weren't sure what that meant, you can kind of like intuit that there is a one-to-one correspondence because both sets have how many elements? 3. So one-to-one correspondence literally means I can make A go to 1 and 1 goes back to A. That's a one-to-one correspondence. And if I do that, I don't leave anybody out from either set. Does that make sense? So if I say A goes to 1, 1 goes to A, B goes to 2, 2 goes to B. So it's one-to-one, it goes both ways. C goes to 3, 3 goes to C. Nobody was left out. So if I gave one of these one more element, I can't set up a one-to-one correspondence because I can't cover that set. Does that make sense? This idea immediately applies to little humans because we don't immediately understand what 1, 2, 3 individually mean. In fact, what do you think the very first experience we have with 1, 2, 3, 4, what do you think our very first experience is with it? This might be a weird question, but yeah. Did you? Sorry. No? Okay.
Oh.
Go ahead.
Like they can see when something's there and when it's not there, kind of like.
Ooh, I like that. That's almost like object permanence. Anyway, sorry. I was a psych major at first. So this idea of when we develop object permanence, so if you have an apple and then you hide it, yes?
Like how there was a study where the baby was watching the puppet show and the puppet would be there and then they'd show facial expressions like the baby understands when the puppet goes away and when the puppet comes back and when it has a friend.
Yeah. So there's a certain age when we're not surprised. Like, if I show an apple and put a screen down and then take the screen up and the apple's gone, there's a certain age where a baby will be surprised about that because we don't develop that until later. All right, I'm sorry, I'm going way off on a tangent. One of the first places we get this is the chant. 1, 2, 3, 4, 5, 6. So that's more like a song, like A, B, C, D, E, F, G. And then we have to realize, oh, A means something, B means something, not just a song. So if I look at A, B, C, I could have a kid start to sing the song, 1, 2, 3, and then they got to realize that number I ended up at represents the total number of things in the set A, B, C. Are you guys kind of with me? So this is really freaky. It should be. But it also should make sense. We're not born hardwired with knowledge, right? There's no Johnny Mnemonic thing where I can jack it into something and upload all this stuff. I know Kung Fu. I can't do that stuff. So I mix my movies up. So one-to-one correspondence literally means I can assign things to each other and I don't leave anybody out. Which is why this set has 3 items. Because it corresponds to 1, 2, 3. That's not my time. A couple of symbols we came up with last time. Is this a true statement given those two definitions? Careful. Let me put the other one down. Is this a true statement? Okay. Does anybody remember what this symbol represented? Equivalent. To be equivalent, what must be true? Each set must have the same number of items. So those two are definitely equivalent because we made a one-to-one correspondence between them. Are they equal to each other? Hell no. ABC is not equal to 1, 2, 3, right? Let me make sure you guys are with me. So there's one level of understanding the idea, and there's the other level of understanding the symbol we chose to represent the idea. So A does not equal B. False. But A is equivalent to B. Equivalency just requires you to have the same number of elements. Okay. I like it. So let me set up some more sets here to give us some more stuff here. I'm going to call C. Oh, look at that. Beautiful. Look at that. A, B, 4Z. I'm going to call D, 4Z. So is this true? What does that say? What's that look like a rounded version of? Less than. So with sets, we would call it a subset. So is it true that C is a subset of D? So that's false, right? False. What about this? True. So when I draw a line through any damn symbol we talk about, it means not. So is it true that C is not a subset of D? Yes, that's true. Okay, what about the other way around? Is this true? Oops. Totally. What does it take to be a subset of? Yeah, all the elements in the first dude must be present in the second dude. Yes? I like it. I like it a lot. Okay. That's your pass. That's true. What's the difference between that symbol and this symbol?
They could have the same amount too.
Not the amount. Yeah, it could either be a subset or it could be equal to. Just like less than or equal to, yeah? So this would still be true. So as long as D has some elements of C or all the elements of C, that would be true. You guys kind of, it's just like less than or equal to versus less than. Is 6 less than 7? Yes. Is 6 less than or equal to 7? Yes, because it's less than. So it's less than or equal to, right? If it truly is, if this is true, and it's not equal to, this is a proper subset. This would be, if that's true, then it's a proper subset. If I just say subset, doesn't that mean it should be a piece of it, not the whole thing? So we call it a proper subset if it doesn't just repeat all the shit. It's just some of them, right? You guys kind of with there? Just a little bit of the shit. Okay. All right. Nothing too crazy yet, but it is like some new symbols to learn if you haven't seen these before. Okay. Yeah. Oh, okay. A question that came up before class started. So just reminding guys real quick, I am in here at 12 until 12:30. So if you want to come early, you got some questions, feel free. If you're like, I can't get here early, man, then don't. You're fine. this idea, what if I said I have a set, I'm going to call it, my set is F. What the hell does that mean? So again, sorry.
It continues.
Continues. Right, so this is really the set 1, 2, 3, 4, 5, 6, and that goes for how long? So how big is this set? Infinite. Kick ass. So this is our first example of an infinite set. Now let me see if I can trip you guys out a bit. What about this one? Is that infinite? Why not? Where does it stop? If you think it's not infinite, it must have a place it stops. Where does it stop? What do you think? The ellipses means keep going. Could I keep going forever? What's the pattern here? Multiples of 3. Is there any highest multiple of 3? No, because if you think you found the highest multiple of 3, just multiply it by 100. Right? You guys kind of with me? So the ellipses mean it's infinite. And I do like at least 3 to set up a pattern. Now, let me ask you something really free. So do you guys agree that's infinite also? Okay. The next point I want to make is nothing too important, but it's just neat. Which set is bigger? Is one of these sets contained in the other one? Which one's contained in the other one? Which one has all of its elements inside the other dude? G. You with me? So which one seems like it should be bigger? Yeah. So the reality is they're the same size. They're the exact same size. Watch this. If I take every element of F and multiply it by 3, don't I get G? Isn't there a 1-to-1 correspondence between the elements? If I just multiply each element by 3, there's a 1-to-1 correspondence. Again, this is just a little side note, it's just a little trippy dude. Infinitely big sets are freaky as shit. And I don't care, they are the same size because I can find a 1-to-1 correspondence. Now you could just go, well yeah, they're both infinite, so they're the same size. But you understand how it's not as clear cut. It does feel like G should be smaller. But it isn't. That's crazy. Okay. So everything we've done before this have been examples of what kind of sets? Not infinite, finite. I love it. So if they don't have the little ellipses, the little dots, they're finite. They stop somewhere. Kick ass. Okay. Does set G have the number 81 in it? Yes. Real quick, this is something we're going to talk about later, but I just want to tell you now. Do you guys know how to tell if 3 goes into a number? How do you tell? That kicks so much ass. So you ready? I can take any number, I don't care how big it is. If I add up all the digits and they add up to be a multiple of 3, 3 goes into that number. So 81, what's 8 plus 1? Does 3 go to 9? Yes. So 3 goes into 81. You with me? All right, so we're going to learn the rules for that for many more numbers. 2, 3, 4, 5. You already know 2. What's got to be true for 2 to go in? It's got to be an even number. You already know 5. It's got to end in a 0 or a 5. But do you guys know 6? Do you guys know 8? Do you guys know 4? Probably not. Okay, so we'll learn that later this semester. Okay. Just a little teaser for later. So a set could be infinite, or it could be finite. And literally, to be infinite, it's got to have these ellipses. Real quick, no, I don't want to do that. Yeah, okay, we'll do that. Don't want to do too much weird shit right now. Oh, let's do this. So that's kind of like the basics of sets. We got set notation, the element of, the not an element of, the subset, the equals, the equivalent, right? Now we have a different way to kind of visualize these sets. Have any of you guys ever heard of what's called a Venn diagram? Yeah. Could you draw a basic Venn diagram? Who could do that? Come up and do it. Who can do it? Draw like a basic Venn diagram. Thank you. Of course. It's the least I could do.
Oh. Sorry, performance anxiety.
Ooh, that's nice. That's fine. Look at that shit. Awesome. Thank you. And then one little thing I could add on to this. You guys know one little thing I could add on? Oh, yeah. I could actually.
I don't know what he's asking.
No, you're fine. That is right. That is true. That's not what I meant, but that's true. I could add another freaking circle. Normally put it there, right? But I could do this. Right? Have you guys ever seen a Venn diagram like this? No. So here's why we do this. Let's say in this circle I have the group of all first-time college students, yes? All first-time college students are in this circle. Over here I have all the people that like D'Amato's pizza. D'Amato's. Real quick little plug. I don't have any stock in D'Amato's, but if you like cheese, go to D'Amato's. So they put freaking cheese in. Anybody know D'Amato's pizza? D'Amato's. It's in La Mesa. You're welcome. If you like cheese, slab of cheese. I only eat it like once every 2 months because it's like, sorry. You with me? First-time college students, people that like D'Amato's pizza. Who are these people? Yeah. So this would be F and D. To be in here, what must you do? Don't you have to meet both requirements?
Yeah.
So what's true? Is everybody with me? And I think last time I did give you this symbol, yes?
Yeah.
Okay, just to remember what these symbols mean. Tell me something about that person there.
Their first time college student.
But they don't like D'Amato's pizza, right? So they're weird. Okay. No, they could just not like cheese, because if you don't like cheese, don't go to D'Amato's. And of course, what about this person? They're not a first-time college student, and they don't like D'Amato's pizza. I loved it. Okay, you guys kind of with me? So that's why we kind of put this box around it, so we can sort of contain the universe a little bit, which is an interesting idea. Let me stop for a minute. Do you guys see when I do this, or when you do this, you've naturally broken this up into regions. And I can identify exactly what's true about somebody who falls into any of those regions. I think that's, I used to joke, last semester we had the same thing, but I always said it was feng shui class? You know, feng shui, like how to, anyway. So there are going to be some problems in the homework that say shade in like this. So then you would just shade in the center part, right? What if I wanted to shade in that? Food. What does this symbol mean? Say again. Or. This means or. So in order to be shaded, what must be true about you? You must be first-time college student or like D'Amato. So how much would you shade? Do I include this person? Why? Go to first time, they have to do one or the other one, right? So what's the only place in this picture that I'm not going to shade?
The circle. I mean the square. The square.
Outside.
Yeah. That's what I mean.
So do these people are good, right? Now I understand, and these people are good, right? And so are these people. So are those people. I would just shade all inside the circles. Does this person either are they a full-time first-time college student or like them? Yes. They just happen to do both. So of course they do one or the other one, right? If I said, okay, I'm going to give you a scholarship if you have above a 3.5 GPA, and you're like, oh yeah, brother. Or you are a first-time college student. You're like, oh shit, I'm both. No, you're good, right? You would get the scholarship if you were both. They wouldn't go, too bad, so sorry, you met both. So or means it could be both. Let me stop for a minute. Any computer programmers out there? Okay, so I won't talk about exclusive order. Okay, I want to do numbers. So there are some problems in the homework where you have to shade some stuff in. Oh, good, I moved it over. Let me come back over here. Doobie doobie doobie. To be really honest, I kind of prefer writing on the whiteboard, but I think the fact that you're surrounded by the monitors and trying to go towards using the projector more often, and I think no matter which way I do it, I write horribly, so I don't think it's going to help that. If you guys haven't noticed yet. So we got, this is and, it's also called the intersection. This is or, it's also called the union. So let's just focus on these two for a second. If one group was Jeff, Ryan, and Bill, and another group was Ryan, Sam, what is M intersect N? This M and N, right? Yes. So and will always make the answer smaller because you have to meet both requirements. So to be in the M and N group, you got to be in M and in N. And there's only one dude that does that. Ryan, the overachiever. Okay. You put him in. What about this? Moon. M or N. What would that be? So to get into the answer, you have to either be in this group M or in N. Everybody. So what's wrong if I do this? It's Jeff, Ryan, Bill, Ryan, Sam.
Said twice.
Yeah, I said Ryan twice. So does he have to clone himself? I'll be right back. So if you just never list something twice. So this would be Jeff, Ryan, Bill, Sam. Okay, just to be lazy. I won't put that on my. So and or are relatively straightforward, if you let them be. What could be a little overwhelming right now is if you're not used to all these symbols, there's kind of a lot of them already, but they're not individually difficult. You just have to get used to them. So everybody got that business? Sorry, bud. Cool. Then we've got this idea. Let me give you, I'm going to kind of refresh it. Let's say that A is 4, 5, 8, and B is 1, 4, 5. Okay, let's see what you guys think. I'm not going to tell you what this means. This could get a little weird, but let's see what you guys think. Give it a second. There we go. Anybody, now obviously that symbol is subtract somehow, but these are not numbers, these are sets of things. What's in them happen to be numbers, but they could be anything, they could be people. So I'm not gonna go 4 minus 1, no. So what do you think this actually means? What do you think? I'm gonna take set A, and from set A, I'm going to remove anything that is in set B. So what am I going to be left with? 8. Cool. Now that does feel a little sideways, right? Because some of you guys understandably be like, well, it doesn't have a 1. How do you subtract? But no, the idea of the symbol used with sets is I'm going to just take out of one set anything that's also in the other set. You guys kind of with me? So this could be like, you could either have, be on team A or team B. You can't be on both. So from team A, I got to subtract the people that are on team B. Are you guys kind of with me? Something like that, where you can't have somebody on both teams. Okay, maybe. I'm
kind of confused how is 8 or how you got.
Oh, So the idea with subtraction is, you take everything that's in A, and you take away from it anything that's also in B.
Oh, okay.
So it's set A minus set B. So like the 1 doesn't matter, because he's not in set A, I don't have to worry about him. He's already out. Somebody already took him out, I'm good. So what am I taking out of set A? 4 and 5. Cool, so I'm just left with 8. What if I did B minus A? One, good. From set B, I take away anything that's also in set A, so I'm going to take 4 and 5 away. Lock it. Okay. So let me do this. On the side here, I'm going to define what the universe is. Okay, so on a lot of the problems, they're going to define for you all the stuff that's possible. So A is 4, 5, 8, B is 1, 4, 5, and they chose from that set of total things. So if I'm going to make 2 teams to play baseball, can I pick somebody who I don't even know who lives 8,000 miles away? No, I'm going to have a universe of people that I know and that I know want to play and that I can talk to, and then I can pick from them, yes? So the little you do just says, here's everything that could be. So you'll understand why this needs to be defined in a second. Can anyone tell me now, what are all the elements that are not in A? And the way we identify that is with this symbol. What are all the elements that are not in A? 1, 2, 6. So that's all that symbol means. The little line on the top just means not that. Maybe. So if I want to see this idea in a Venn diagram, if I've got W, C, I have no idea what they mean, and this is my U, where would you shade for not W? Not just C. Basically, you can answer the question by telling me what you wouldn't shade. You're going to shade everything except the W circle. Everything that is not in the W circle, you're going to shade, correct? Because that means not W. So will I shade in here? In here? Why would I not shade in here? Is it in the W circle? Yeah, so I'm not going to shade in there. I can only shade things that are not in W. So can I shade in here? No, because it's not in W. So I'm going to shade everything that's not in W. Okay. You guys kind of with me? Because this literally means not W. So I just shade everything that's not in W. I like it. Okay, yeah, let's do this. So let me give you a Venn diagram that's been done. I want to ask you some questions about it. What do we have? Yeah. Whoa, one outside of my universe is free. So in this Venn diagram, B means likes bacon. H means has hazel eyes. And L means, okay, Jeff, sure, works for Lyft. So I'm going to throw some numbers in here. Doesn't really matter, but let me just keep it the same. Why not? Okay. Can anyone tell me how many people like bacon? So, I'll tell you this much. 11 is not right. 11 is not correct. 11 people like bacon, but they don't have hazel eyes and they don't work for Lyft, correct? I want to know how many total people like bacon. So if you like bacon, where are you in this picture? You're in the bacon circle, which sounds amazing to me. I want to be in the bacon circle. So yeah, I like some of you guys. I could see you guys kind of count. Yeah. So how many total did you get? 17. Do you guys see that? 17 people in this picture like bacon. Do you guys all see that? How many people like bacon and they have hazel eyes and they work for Lyft? This person would have to be in every circle, correct? Or these people, I should say, without giving it away. There's only one person that's in all three circles, yes? That means they meet all three requirements. So let me ask you, this could get a little trippy, if it isn't already. What symbols would you use to describe the section in the middle, this one dude? What's true about this dude, this person? I don't know if they're a dude. They like bacon. I think I heard, there's a magic word I gotta hear. They like bacon and what? Have hazel eyes. And work for Lyft. I like it. So every time I add an and, my group I'm talking about gets smaller. Because you have to meet more and more requirements. If I said, to get in my house, you gotta like bacon, you're like, all right. I'm like, wait a minute. You have to have hazel eyes. All right, wait a minute. You have to have work for Lyft. Oh shit, who the hell are you? I don't work. You have to leave. You have to meet all three requirements, which makes sense that it's just one person there in the middle. You guys kind of with me? You're gonna have problems just like this in the homework. Can somebody tell me how many people have hazel eyes and work for Lyft? 3. To have hazel eyes and work for Lyft, you have to be in both circles, correct? How many people are in both circles? 3. You guys with me? So, these right here would be hazel and Lyft. I'm sorry, these right here. There we go. What I was about to ask you is, how would you identify these people? What's true about those 2 people? Yeah, they don't like bacon. They have hazel eyes. They work for hazel eyes. They have hazel eyes, and they work for Lyft, but they don't like bacon. Okay, maybe. And that's fine, because I'm going to eat their bacon for them. I'm here. Like you guys, if you like fish, you can have all my fish. Don't like fish. Have you guys ever seen, I know at least a couple of you, because you told me about one more circle, but how many of you guys have ever seen like a tri-circle Venn diagram? Yes? Not quite as neat as the Triforce, I'm sorry. Okay, so let me do this so that I don't bore the shit out of you. I'm gonna give you this, and I want you to work on, what have you done, Jeff? Yeah, okay. I want you to work on the side, and I want this side, the one with all the words. I want you to work on the other side, the one with the Venn diagram on it, right? So I'm going to give these 2 to you, and then I'm going to try to have you work together like we did the other day. So let's see, oh, I'm sorry. Yeah, if I could just count, my job would be so much easier. Okay, did we do this? Can we do the same thing we did before? Can you guys work with the girl behind you, and you guys here could work like you can turn around, right? Same thing, same thing, same thing, same thing. Yes, can we do this? Can you guys turn around and work with these guys? Okay, okay. And then you guys, I'm really sorry. You're my on Rosa. I work. Wait, I think I do. I think I do. Oh my God. I think I do.
It's okay.
There it is.
Thank you so much.
It's like a bottle.
This is the only class I need.
Oh. I feel strangely honored about that.
So the universe is all the possible numbers. If it's everything that's in the universe, so is it no real? And everything that's in A.
So this group, if you want to say this, didn't you already figure out what not to do?
Yeah.
Oh, I thought it meant like.
All you have to do is go A. And just write reunion universe. Which literally means slap ass. So put everything as an A or a number. Yeah, you just don't write it if it happens.
That's what I am.
Yeah.
See, that's what I was.
So if I said 7 is not an element, that means is 4 not an element.
So would it be like?
Is 4 an element or not? Is 4 in the set? Oh, don't we go here? That's B. I want to know but not B. Is 4 in and not B? So this is false, because 4 is in B. Okay.
I do not see.
Understood. It's like a double negative. I mean, oh, like in here, that's how I did on this section. So like do these background. I tell you the numbers, and you tell me what I would put here to lead to All right, guys, I am going to start to catch up to you. So guys, what does this symbol mean here? And. So to be in the answer, the number has to be in A and B. So what are the only numbers that are in A and B? 7 and 26. Kick ass. Okay. What does this mean? Everything is not in B, and of course, thank God I told you what could be in B. Otherwise, you'd be listing numbers for the rest of your life. Do you understand why I have to give you a universe now? I mean, so what could have been in B, but is not in B? 0, 3, 4, 18. Okay. Does it have to be in that order? I don't give a shit. Doesn't have to be in that order. So really, the most important thing here is to understand what the symbols mean. If you understand what the symbol means, you now know how to attack the problem, right? Do we now know what the set not B is? We know what the set not B is. If I have a question that references not B, I'm only going to look at this. So this one says A union not B. That's all I got to worry about. I understand some people were looking at this dude. Why would you? He's not involved in this problem. He doesn't mean shit to me. So right now, all I care about is A, not B. So what does this symbol mean to do? Combine them. It's union. It actually means unite them, put them together. Just don't list anybody twice, right? So I'm just going to list all the elements that are in A or in not B. So what I normally do is this. I pick one of them and I just write all the stuff. 4, 7, 8, 26. Now what have I not written so far that is in not B? 0 and 18. And 3. Okay. So can you find A in here? Yes. Can you find not B in here? Sorry?
The 8 in where it says 4, 7, 8, would it be 18?
Oh, I see what I did. I'm so smart. There we go. Okay. No, you're pleased, your God. I'm not one of those math. Have you ever had a math teacher's like, I don't make mistakes. I don't know. Dear God, I make mistakes. Are you kidding me? I'm just a human. So yeah, I wrote that as 8 instead of 18. And then what about this here?
A without.
Yeah, I write everything that's in A that is not, and I just take everything that happens to also be in B. I take it out. So what am I taking out of A? What am I going to take out of A? 7 and 26. So what's left in A? 4 and 18. Okay. So the minus symbol with numbers does not mean the same thing as it means for sets. Right? Yes?
How does the third one work? 4, 7, 18.
That's what he said. Yeah, so that lists everything that's in A or is in not B. So the way I normally do an OR problem is I pick one of the sets. In this case, I picked A and I just wrote all of its shit down. And then I looked at not B and I said, who have I not written yet? Because that symbol literally means unite the two sets together. Okay, let me see. Yes?
Does it matter if you have the squiggly lines after? Or you want to just...
Yeah, you gotta have those little squiggly lines. Is that the little set notation stuff? Yeah, these little dudes. And they don't have to be pretty, because look at mine. Okay. So literally, they should look like this. Right? But you know, this is what they look like in practice. Okay. We'll talk about this here in a minute. That looks like it's supposed to be somehow multiplying them together, correct? And that's true, but it's a little weird. So we'll talk about that in a minute. Is this true? So what does this say? 4 is not an element of not B. So is 4 not in not B? Is 4 not in not B? No, 4 is in there, isn't it? So this is false. Or you can say no. Let me ask you this. Is 4 in not B? Is 4 an element of not B? So is 4 not an element of not B? No. If 4 is in not B, is it true that 4 is not in not B? No. Okay. I love you guys. And what does this mean here? Equivalent. And in order to be equivalent, must be true. Same number of items, right? If you want to be really technical, you have to be able to create a one-to-one correspondence between the two sets. But yeah, do they both have the same number of items? Yes, so this is yes. I like it. All right, we'll come back to this. So I helped one table out with this. I'm not sure how everybody else did. Let me ask you a seemingly unrelated thing. Don't freak out. If I ask you to do this problem here, yeah, what would you do first? what's the very first thing you would do? 3 minus 5, yeah? You go to the innermost thing, correct? And then you kind of work out from there. So you're all like, Jeff, did you take your meds? What's it got to do with this problem? When you draw this picture, how many circles do I need? 2, because one of them is going to be what circle? Left-handed. The other one is artistic. I like it. What's the innermost thing? What has to go in here? True. So what goes in here? What number goes in here? 2. 2 people are both left-handed and artistic. How many people, that's all I've done so far, correct? How many people are already in the left-handed circle? No. How many people in my picture are already in the left-handed circle? 2. How many people are already in the artistic circle? 2. How many total people are supposed to be left-handed? 5. So what do I put? 3. You guys, now listen, I want you really with me. It's completely fine that you might have made a mistake with that because it's not intuitive. You're like, it should be a 5 right there. Crazy. You said 5 left-handed people. Do you agree with me? There's 5 total people in the left-handed circle now? So once you see that, now you know how to be careful. There will be some problems with 3 circles, which is always exciting, but you always start in the innermost little dude. And then once you put a number there, that's how many's already in every circle. Then you kind of work out from there. How many people go out? I'm sorry, I still got to finish the artistic. What do I put?
17.
Good, so that makes a total of 19 people in there. How many total people are here?
22.
22, kick ass. You don't count anybody twice. 3 here, 2 there, 17 there. 22 people. How many total people do I have?
38.
So how many people are out here? 16. So if I say how many are neither artistic nor left-handed, we just answered that question? 16. Here's Jeff down here. Jeff is out here. I'm definitely not left-handed, and I'm definitely not artistic. I don't know if you picked up on that. How are we doing so far? So the purpose of these worksheets is not a quiz. So if you don't understand something, this is a beautiful time to not understand it because that's the purpose of this. So let yourself make mistakes. I have a shirt that I finally got. It says, mistakes allow thinking to happen. Math. Love that shit. So I'm going to start wearing that bad boy. You want to make as many mistakes you can on the things I don't grade. Just to get them cleared up. Why is it a mistake? What was I thinking wrong? What's the right way to do it? You can't learn that if you don't make a mistake in the first place. So now I give you a triplet. A little triple dude. So which regions correspond to A and B?
2.
Yeah, 2 and 6. Region 2 and region 6 are in both circles, correct? They're in circle A and circle B. Which, is everybody cool with that? Yeah. Which red regions correspond to Buck? B, they have to be in B or C, yes?
What if we add up the 2 and 6?
Oh, I'm sorry, I'm with you. I understand. Problem number 2 is numbers of people. Problem number 3 is just regions. So 1 literally means just region 1. Doesn't mean one person. You with me? Okay, I understand. So this doesn't mean 2 people, this just means region 2. It's just a quick way to identify the parts of the circle. Yeah. I like it. Which regions correspond to B or C? 2, 3, 6, 7, 5, 4. I like it. Just list everything that is in B or C. Now, here's the hard one. 5, 6, and 2. First off, I understand the word denote. You don't see that too often. You're like, do you want me to play a piano, hit the D? I don't know. No, not denote. It's just how would you write something like A intersect B? Just really A, B backwards. So I tell you the answer is 5, 6, 2. What would the question have been to have that as the answer? Does anyone think they have a possible? Yes. Let me write it down. What you got?
Do I just say like all of them, or do I just say one?
So your answer should look something like that. Maybe it's bigger. What you got?
I have like A and B, and then A and B and C, and then A and C.
Oh, I
Well,
see.
I'm like in different rows.
I see. I understand. I want one
Okay.
line.
That's what I'm doing.
I'm with you. I want one line. And what other symbol could we use? A minus symbol. We could use not. We could use whatever. So how about this? Do you agree that A and B is part of the thing? It's 2 and 6, correct? Okay. What else isn't 5 and 6 also? How do you write 5? What's 5 and 6? That would be what? 5 and 6. That would be A intersects C, correct? So this picks up 2 and 6. Get rid of this so it doesn't look like a knot. This picks up 5 and 6. Don't I want to just put those together? So then, couldn't I just put in the middle? A and B is 2 and 6, yes? A and C is 5 and 6. So when I unite those, don't I get 5, 6, and 2? Don't I get those regions? That to me is the most straightforward way to do it. There are other ways to do it, but it has to be one line. Yeah. Maybe. And again, is that intuitive? Is that something you guys have done a lot of? Have you guys ever done a problem like 3C? Ever? All right then, get off your own back. That's weird as shit. I'm not grading it because it's weird as shit. I wanted to put that down there just to see what people came up with. If I do it on the quiz, then you can kick me. All right. So let me come back to this question. Let's talk about this question. Right, what the hell is that? Do you guys feel any better about some of this? When you first looked at it, I know a few of them were very like, how the hell, what the hell? But that's one reason why you do this, is so I can feel out where it is we're sort of not getting it. So let me focus on that weird-ass multiplication symbol. I need some paper. Darn it. Where did I put all my paper? Are you down there? You are down there. Jeff, you're awesome. All right, so let's say that the set H is A, B, and the set W is 1, 2. Okay. Actually, let's make this a little more interesting. Let's make it 0, 1, 2. So H is AB, W is 0, 1, 2. By the way, just so you understand, the entire semester is not going to be talking about sets, okay? We're just there now. It's not going to be forever this, okay? AB and 0, 1, 2. So in terms of set mathematics, when you see that X, I'm going to write a name down. I'm going to write a word down that's based on a name. Cartesian. Has anybody ever heard of Cartesian stuff? You guys remember when you graph stuff in algebra, don't you have an XY plane? All right. So a little history. Stay with me, guys. There's a guy named René Descartes. French dude. René Descartes. There's an urban legend that he was sick one time. He's laying in his bed in his room. And back in the day, there's no freaking phones, there's no TVs, there's no radios. He's just watching a fly move around on the ceiling. You with me? So the urban legend says he was like, I can see where the fly is based on how far it's gone this way and how far it's gone that way. He developed the XY plane. So we call the XY plane a Cartesian coordinate system after his name, René Descartes. Are y'all? So it's C-A-R-T-E-S. So we just made it an I-N to make it sound nifty, like artisan. So it's Cartesian. You guys with me? Okay. So in this case, now tell me real quickly, if I want to find a point on an XY plane, how do I identify a point on an XY plane? Yes.
It's coordinates.
And what are the coordinates composed of? An X piece and a Y piece. So it tells me how far to move left and right and how far to move up and down. You with me? Okay, so there's a connection with this. So this is called the Cartesian, this is called the Cartesian product. And all it says is make up all the points you can where elements of H are first and elements of W are second. What the shit does that mean, Jeff? I'm going to make the point A0. Element of H is first, element of W is second. A0, yes? Could I also make A what? 1. I could also make A2. All right, now what's the other 3 I can make? B0. B1. Holy shit, Jeff. B2. That is the answer to H cross W. Now let me ask you this. I don't remember if I've shown you this notation before, but what's the number of things in H? What's the number of things in H? 2. That's crazy. What's the number of things in W? 3. What's the number of things in H cross W? 6. Isn't 2 times 3 6? This is a fundamental, crazy, base level place where this symbol ends up meaning multiplication. Do you see how that does lead to multiplication if you look at the number of things in the sets? You guys kind of with me? So let me ask you this. If I had a set of 5 things and a set of 4 things, how many things would be in the cross of those two? 5 things, 4 things. 20. So look back at the question on the worksheet. How many elements would be in A cross B? Yeah, because A is 4 and B is 4 things, right? So there will be 16 things in there. Can you tell me one thing that would be in there? 4 7. 7 7 would also be in there. 18 blah blah blah. All the possible pairs you can make, but I know ahead of time there would be 16 of them. Does that make sense? Yeah, like, you alright? So all that means, when I see the time symbol for sets, is just, let me go back a step. It means take elements of this, comma, elements of this, one at a time. As many as you can make. So would this be the same if I did W cross H? Would that be the same answers? No. W cross H would be 0A, 0A, 1A, 2A, 0B, 1B, 2. So it's the first dude first, the second dude second. Is that all right? So it's just how many, all the points you can make between the two sets. Yes?
So wouldn't you still get 6?
Totally, you would still get 6 elements. But the elements would be 0A, 1A, 2A. Because now W is first. So he gets to be first. Yeah.
Do we have to write it out each time like that, or just time?
Only if the problem asks you. So some problems of them we're going to say how many, and some of them will say list all of the, yeah. Yes?
So it doesn't matter if there's like duplicate numbers.
Doesn't matter. 7 7 is a distinct point. So I'm not going to throw it out just because it uses 7 twice, because this is a distinct location. Yeah. Okay. Okay, I like it. How you guys doing? Okay. All right. Oh, I have done it to myself now. Let's see. Oh, we're going to get into, here we go. All right, I got a few definitions to throw at you, which is always exciting. And then we're going to get into our first examples of different civilizations' numeration systems. Different ways other civilizations represented numerals. I have no idea what that phrase makes you feel like. Okay, we'll find out. First thing, a couple of definitions. With numerals, all right, let me just say this. Does anyone think they know the difference between number and numeral? Number versus numeral. Say, sorry?
Is it like when it's a numeral?
Oh, I see, okay. Roman numerals, let's try it like this. Do you guys know the Roman numerals? What's 1? It's like an I. What's 5? V, okay. Roman numerals, right? What about does anyone know what our system is called? We stole it, like we did most everything. English, like words and numbers, we stole it from other people. We actually use the Hindu Arabic numeration system. So Hindu Arabic numerals are 1, 2, 3. 1 in Roman numerals would be like an I. 2 would be 2 I's. 3 would be 3 I's. So numerals are the symbols we use to represent the concept of number. You guys with me? Yeah. So different civilizations came up with different symbols. All the symbols we use were made up at some point, completely made up. But the concept they represent was not made up. There's a concept of 5, right? Now what's kind of interesting, a little side note is, do you guys know, all right, can you guys tell me how many dots there are in that just by looking at it? Okay. Can you guys tell me how many dots just by looking at it?
No.
You have to count, don't you? Okay. So at some point, around 4 or 5, beyond that, we have to count, right? So that's a little side note. We can, so this represents the concept of the number 4. If you're Roman, how would you represent that using a numeral? Do you guys know? 4 in Roman. IV, because it's subtraction, and we're going to talk about Roman numerals later today. You guys up with me? If I am Egyptian, I would actually represent that with 4 staffs. Right? They also look like Roman numerals, which is interesting, at least to that point. Okay, stay with me. So we have the idea, we have a numeral captures the idea of number of things. So number is a concept, numeral is a symbol we use. Very well used paper, John. Keep going. Real quick, numbers. How can we use numbers? There's an idea called cardinal numbers. Right, now when I hear cardinal, I normally think of a bird, or I think of the dude in church or something, the cardinal. Cardinal numbers is really just what we think of when we think of numbers. First thing we think of is counting stuff. Cardinal numbers are the number of items in a set. Whereas ordinal numbers, what do you think that word references? Ordinal. I like that. Order, exactly. So if you're 4th in line in a deli, that's an ordinal number. The 4 doesn't mean there's 4 people in the deli. It means you are the 4th person. It's your order. Are you guys kind of with me? Not the order you place, but the order you're in. Okay. So ordinal numbers are exactly that. That reference the order something is in. You're the 1st person in the race. You're the 7th person that came through the door. Those are ordinal numbers. And then finally we have the one that's a little bit boring, but identification. That's like your social security number, jersey number if you play sports, right? The zip code you live in could be an identification number for you. You guys kind of with me? So this is kind of like the main 3 ways that we use numbers in everyday life. Oh, yeah, we already talked about that. That's awesome. Oh, okay. So one more thing I want to talk about, then we can finally get into like Egyptian numerals and some stuff. How do I order whole numbers? How do I find out which one's bigger or smaller? So when you're a little human, first learning numbers in the first place, how do I tell if 5 is bigger than 2? How would I know? So what's the very first experience we have with numbers is normally teaching a kid to go 1, 2, 3, 4, 5. When they first learn to do that, they have no connection with what the hell those represent, but they can say the words. Then we introduce what 2 means, what 3 means. So with the chant, 1, 2, 3, 4, 5, how could a kid figure out that 5 is bigger than 2? It comes later in the chant. I like it. So the very first experience we have with the ordering of numbers is where they occur in the chant. And I keep saying chant like, they're wearing little hoods. 1, 2, no. It's a little song thing. It's not quite as sing-song as A, B, C, D, but so the very first experience we have of this is with the chant. The later they happen, the bigger they are. Later equals bigger. What's another way that we could order whole numbers? What's the way you could do it with older students?
So like quantity?
Okay, good. All right. And this could work with younger people too. So the second way is if you have one set with something in it and another set with stuff in it, you look at the number in there, number in there. So if a kid looks over, if the kid has, how do you want to say this? Jeff, you've left yourself so much room. Toy, and another kid has toy and toy and toy and toy. How does this kid feel? He's looking over this kid. This kid is like, what the shit? Sorry. So you're exactly right. You can tell by observation that there are more things in this set. You might not have related the idea of the number of things in the set to a numeral yet, but you know there's more in that set. It takes longer to make a one-to-one correspondence with them, for example. Right? So the number of things in A is less than the number of things in B. And that's more of a visual thing, right? And then finally, the one that what's the way to tell is on a number line, correct? So on a number line, why is 3 bigger than 1? Because it occurs further to the right. I love it. So on a number line, it's what occurs further right is bigger, and the chant is what occurs later. And with groups of things, you can tell kind of which one's more than the other one. Okay. How you guys doing? All right. Okay. Oh, all right. So let me tell you this. This is nothing too crazy. What's really trippy? All right. This is one of my favorite sections we're about to do. I'm not sure how that makes you feel. There is a group of people who lived on Papua New Guinea. You guys ever heard of Papua New Guinea? Little island? All right, so there's an island named Papua New Guinea.
Is that the one from Jurassic Park?
No, that was. Oh, I almost had it. No. No, it wasn't. What these people did to identify the names of numerals was to count along their body. So the name of this meant 1, and this, and so if they wanted to tell somebody how many things, they could point to their thumb, which meant 5. You guys kind of with me? And they did it up and down, and they got up to 27. So if you search on Google Papua New Guinea numeration system, it'll actually have pictures of going around their head and coming around this way, and they got 27 things. So if how many people are coming over and they point to the shoulder, that might mean 18. You guys kind of with me? All right, let me just stop there for a second. I need you to understand. If we are brand new humans in the world, we don't know shit. At some point, it's going to be important for us to know how to communicate a number of things. There are tigers coming. Oh, if it's 1, we could get. If there's 7, we're screwed. So how many? And you're like, we haven't invented that yet. We're dead. You guys kind of with me? So it's going to be motivation to be able to communicate to somebody the number of things that are coming our way or whatever. Okay. So this is interesting. That's really kind of neat. Who knows why they did this? But they just decided, yeah, let's just do that. And then I can tell somebody all I have to do is this. And that means 11. Sorry, I haven't looked at it in a while. Forget what's what. But you guys semi with me? So you guys can look it up and then teach me if you want to. Well, this means 20, Jeff. Okay. We're not going to talk, Papua New Guinea's numeration system is not going to be part of what you have to do, okay? I'm not going to make you come up to the front of the class and show me 17. But I'd just like to tell you that because all the different civilizations had completely kind of different responses to how do I identify how many. So let's talk about the Egyptians. Now, when I talk about Egyptians, communication, what do you guys think of? Hieroglyphics, I love it. So that's pretty much what they used with this. What's really cool about this lesson is if you go to like the Museum of Man or a museum that's got ancient Egyptian stuff, you'll go, oh shit, that's the number we talked about. And you'll see in a minute there's something related to Chipotle somehow. In a minute, you'll see. And it's not indigestion. So the Egyptians, they used what's called an additive system. So our system is multiplicative in a way, because what is 4, 3? If I write 4, 3, what does that mean? If I write 4, 3, it means what? 43. Why 4T3? Why 4T3? What does that T mean? What does the 4 really? It means 4 tens, 4 times 10. So our system is inherently multiplicative, correct? In fact, it's a place value. If I put the 4 here, that's 10. If I put the 4 in the next place, that's 100, right? It's 400. Are you with me? Are you with me at all? Okay. So our system is multiplicative, additive, and place value all at once. It's crazy. So the Egyptians, they just had an additive system. So what the hell does that mean, Jeff? I don't know. Let's first talk about their numerals. 1 was a staff. Ooh. 10 is a heel bone. 100, holy crap, Jeff, was a scroll. 1000 is my favorite and least favorite. Is a lotus flower. So I just want to show you, if you're worried because you can't draw well, you are fine. Look at me. 10,000. Of course, what else would you make it? It's a pointing finger. Right, so you guys could probably draw that better than me. That's okay. 100,000. It only makes sense. It's a fish. I draw it like that. The symbol in the book is different. I don't care. Little fish dude is 100,000. My favorite number of all time in Egyptian hieroglyphics is 1 million. It's an astonished person, like somebody won $1 million. I'm not making that up. So if you go to a museum and you look at the tablets, you'll eventually see symbols like this, and it could very well mean the numerals. It's kind of nifty. So here's how this works. If I want to write, if I'm an Egyptian, and I want to count like an Egyptian, I'm going to write the number 423. How many hundreds do I need? So how many lotus flowers do I draw? 4. Each one is 100, right? So I'm going to draw 4 of these guys. Oh my God. Oh, I'm doing 1,000. Why am I doing 1,000? Let me do it over here. 400s. There it is. That's better, Jeff. 4 scrolls. I love you guys. You're like right on it. Like, dude, try it. What else do I need? I need 2 tens, 2 heel bones. And I need 3 staffs, right? And the nice thing is, very often they would be in their own little section, so they could actually be whatever order they want to put them in. So with Egyptians, order doesn't matter. For us, does order matter? 4, 2, 3. Is that different from 2, 3, 4? Yeah, holy shit, that's very off. Egyptians, it doesn't matter. It's just additive. I just have to have the right number of each picture. What sucks about the Egyptian system? How would you write 9,999,999? So their system is not very efficient, but they're like, this is what we got. And then other civilizations started to improve on this. How do you guys think about Egyptians? By the way, I'm not going to make you memorize the shapes. I will give you the shapes on a test or a quiz. I will tell you exactly what you need to. There are a few things you're going to have to memorize. Egyptian shapes are not one of them. You just have to know how to put them together, right? Yeah, that's not too bad, right?
You said order is not right.
Nope. So I could have put these up top. As long as in the little section I could see 4 scrolls, 2 heel bones, and 3 staffs, that's 423. I like it. So what is, let's try it the other way around. What is this number then? Good Lord, Jeff. Holy shit and a half. Okay. What is that number trying to be? 50,000. So 51,000, right? 51,020. 51,020. So the Egyptians, now real quick, just to make sure you understand, the Egyptians had some advantages. Look how many symbols we have to write to represent a million. And they just take one symbol. You with me? But the minute you have some 9s in there, it's like, oh shit. Okay. Let me ask you, I already asked you a few things about Roman numerals. So help me out. How would you write 1 in Roman? So this is Hindu Arabic. And this is Roman. Yeah. That's how you would write it. Now, very quickly, I might as well tell, well, here, let me do a couple more. How would you write 2? How would you write 4? So, we see our first rule. Our first rule the Romans set up. It's not us, the Romans did it. If you want to change it, make a time machine, go back in time, convince them. They were a little bit stubborn, so you probably won't be able to. They said, I cannot have the same symbol more than 3 in a row. How do you write 3? I. How do you write 4? You can't use I. They said, nope, sounds silly. You can only have at most 3 of the same symbol in a row. You with me? Now, you all know IV is 4, Roman numeral. How the shit, what is V? Okay, so why in the hell would IV mean 4? What operation is inherent in that? Subtraction. So, the next thing about Romans, and by the way, I have a handout that's got all this shit on it too. The next thing about Romans is, if I have a smaller symbol in front of a bigger one, that means subtract. That's why I get 4, because it's 1 in front of 5, so 5 minus 1 is 4. Okay. How do you write 6? So see how Romans are basically an additive with some adjustments, a little bit of subtraction. You guys see that? How do I write 8? V, I. So can I write 9 as V, I? Yeah. How do you write 9? Good, because what's 10? X. So 9 would be 10 minus 1. So if you see a smaller in front of a bigger, subtract. Notice how we do not write 8 as IIX, because it's only one thing in front of another thing that means subtract. You can't put multiple things in front of the thing. Does that make sense? And again, this isn't me making up the rules. It's the entire Roman civilization. So we're going to talk about what they did. Okay. What's the next new symbol up from this? You guys know? Yeah, how do you write 7? How would you write 17? What do you think? X, V, I. I like it. Not too bad, right? How would you write 39? XXX. That's 30, right? And then how do you do 9? Careful. IX. Now, I want to do this for a reason. I have 3 X's in a row. And then there's an I, and then there's an X. That's allowed. You just can't have the same symbol immediately more than 3 times in a row. So that's how you do 39. Anybody ever watch, this is not a requirement for this class, dear God. Anybody ever watch the Super Bowl? Anybody watch the Super Bowl mostly for the commercials? Nowadays, you can just look at YouTube to get the commercials and not have to worry about the Super Bowl. Okay. They would use Roman numerals because they could put them in like a graphic, like they're all stone, and then they could drop them. Super Bowl 47, wow, right? How would you write 47 in Roman numerals? Here's where things get a little weird. We don't know how to, well, can I do XXXX? Shit. So how would I do 47 then? So what is 50? Let's talk about 50. 50 is L. So how would you write 47? To make 40, what do I do to 50? I have to subtract 10. So how would you write 40? XL. So 40 would be XL. And then how do you write 7? Why is this subtraction? Because a smaller symbol in front of the bigger, right? XLVII, that would be 47. So you can see that in like rock graphics dropping Super Bowl 47. The funny thing about Super Bowl 50, I wish they would have done that. They could have just had a big ass rock L. It's gonna drop. And I would have loved that. But no, of course they didn't do that. I'm like, damn it. Super Bowl L. He's like, oh my God, so lost. Okay. So instead of going step by step, the next symbol up would be 100. And how many, what do you need 100 of, bless you? What do you need 100 of to make $1? I love you guys. Pennies, you say everything except the right thing. Cents, right? So C is 100. 500 is, of course, D. Just this. Does anyone know what 1,000 is? M? Yeah. All right. Let me give you this before I forget. Yeah. Oh yeah. It's on the other side. All right. Damn it to me. I'm so sorry. So on the back here, you got the Egyptians. Oh, I forgot to ask this. Do you think the Egyptians would have needed a symbol for 0? No. And they didn't really have one. They had a word for 0, but they didn't have a symbol for 0. Here's the Romans. Look at this, 3 things, right? So if there's 2 symbols where this first symbol is a number smaller, that's the thing about subtraction. You with me? So read with me. The weird thing about this, symbols can only be subtracted from the next 2 higher numbers. So if I wanted to write 499, I could not do ID. So everybody understand? I is 1, D is 500. So that does not mean 499. Why not? Talk to the Romans. I don't know. It's just you can only, so IV makes sense. IX makes sense. Those are the next 2 higher things, correct? So I can't do IL for 49. I can't. Why not? They didn't want to. Too bad for us. You guys semi with me? Number 2 is basically otherwise it's addition, right? If you see any pairs where the first number is smaller than the second, that's subtraction. So look how I break this problem up. Break this problem up. addition. CD, the first one is smaller than the second one, that's subtraction. LX, so you want to look for pairs where the first one is smaller than the second one. It's the first thing you look for, because that's the only things you're going to subtract. Everything else you're going to add. Okay, I like it. I look very excited. And the third thing is you never should or have to use 4 things in a row. We already talked about that. Okay. So that's not too horrible, is it? You guys have done a little bit of Roman stuff, and if you do any outlines for English, you normally use the Roman numerals for the. Yes. Okay. This just takes it a little further than you used to. One little thing I don't think I put down here is some of you guys I think wanted to write one like this. Maybe? So the problem with that is if I wanted to write 5,000, Why can't I just go, What's wrong with that? Can't have more than 3. So how do I write 5,000 then? Well, how do you write 5? V. And to make 5,000, you put a line over it. So every time you've ever seen, so this kind of bugs me, and of course it does, because I'm, a picky geek math teacher. Anytime I've seen this, that means 1,000 in the wrong way. So if you put a little line over something in Roman, that's times 1,000. You guys with me? Okay, I like it. So it shouldn't be there, damn it. Okay. So if you ever see this, that literally means 5,000 in Roman numerals. Okay. I like it. So last thing for today. I'll just say a little bit about this. Oh yeah, it's underneath here, Jeff. Last thing. So we got Egyptians, we got Romans. Don't worry about Papua New Guinea. Just want to say a little bit about Babylonians, who will affectionately be known as baby from now on, basically. The Babylonians are the ones that we stole the idea for how we keep time. How do we keep time? 60 seconds in a minute, 60 minutes in an hour. Can somebody tell me how many seconds are in an hour? 60 seconds in a minute, 60 minutes in an hour. How many seconds in an hour? 3,600. Yeah, 3,600. 60 times 60. Are you guys kind of with me? Do you see how all of that is based on 60? Or until you get to like 24 hours in a day, but oh well, we get all crazy. What's our system based on, by the way? What's our number system based on? What's our number system based on? 47. What's the T mean? 47. 4 tens. It's like a quick way to say 4 tens. 14. You kind of with me? So 11, we could have called that 1T1 instead of 11, but we just didn't, thankfully. Our system is based on 10. I don't know why it's based on 10. We'll never know why it's based on 10. So if we had 8 fingers, let's not take away our thumbs or else we don't evolve. If we had 8 fingers, our number system would be based on 8. What would that look like? We'll see in section 2-3. All right. Our system is based on 10. Babylonians' number system is based on 60. So what does it mean for a number system to be based on 10? Let's talk about in Hindu Arabic for a second. If I look at this number, what is this place in Hindu Arabic? The ones. What's this place? Tens. What's this place? Hundreds. What's this place? How do I keep moving from one spot to the next? I multiply by. That's what I mean by our number system is based on 10. Okay. Babylonians, their number system is based on 60s. They don't use these symbols, but just to show you, if they did use these symbols, this would be the ones place. This would be the 60s place. Jeff, make a 60. What would this place be? 3600s place. What would this place be? 60 times 3600, right? That would be 216,000s place. Don't judge. There wasn't much to go on back then, so they just made some weird shit up. Why did they like 60? Why do a lot of civilizations use 20 or 60? Because what's one of the most important things for an ancient civilization? What's the most important thing as a human? We have to eat. So, yeah, like that's how I eat. So what's important about eating? Growing food. What's important about growing food? Knowing the cycles within a year. And how long's a year? Roughly 360 days. So 360 was sacred to ancient civilization. So Babylonians directly used 60, which goes into 360. Do you kind of see what I'm saying? This is possibly, we don't really know exactly, but possibly why they chose that. So, just to kind of lay down a little groundwork and then we'll head out. Babylonians had a place 60. So real quick, before I show you their symbols, if a Babylonian wrote 3-1 down, for us that would mean 3 tens plus 1-1, 31. For a Babylonian that would mean 1-1 and 3 60. So what number would this actually be? What's 3 60s? 180 plus 1. So this would mean 181. So each of their places is based off of some multiple of 60. That's a little crazy. Last thing I'll share with you. They only had 2 numeral symbols, which is insane. They had a symbol for 1, which actually looked like this a little bit. I'm going to represent it with just that. So that's the number 1. And they had a symbol that looked like this, which I'm going to make look like that, which is 10. Real quick, why was the symbols that? Because they had clay tablets. They had these things they would do like this, and the end of the thing looked like a little triangle. So that's the easiest shapes to make. So that's 1, and then if they do bam, bam, that's 10. See how 10 is just 2 1s put together? So I'm going to represent it with a Pac-Man with a less than a symbol and a 1. So if I wrote this, what number would it be? 31. You with me? Okay. This would be in the 1's place. If I wrote this, what's in the 1's place? 31. What's in the 60's place? 1. So what number would this mean? 60 plus 31, 91. Y'all look very excited. Okay. So we'll get into Babylonian number system, Mayan number system. Mayans, by the way, are what's related to Chipotle. I haven't gone to Chipotle in a long time, but if you go to Chipotle on the wall, they have these faces, and that's related to the Mayan sacred hieroglyphs for the numbers 0 through 20, or 1 through 20. Yeah. All right, guys, that's plenty. I'll see you next week.